Very good morning to everyone. Welcome to the GovTech Data Science Connect Edition 21. My name is Prem and I'm from Datarobot, and we're really excited to be here today to share how Datarobot can support you and your agencies in leveraging AI, taking your concepts from ideas to value supported with augmented intelligence. I think we have a good number of participants on the call, so perhaps we can just get started. On the call today, we've got a couple of our colleagues from Datarobot. Myself, my name is Prem. I'm the account executive. I look after the public sector business within Datarobot. We've also got a couple of my colleagues, Wei Chong, who's our customer-facing data scientist. He looks after the technical success and provides guidance and enablement in data science and the use of the Datarobot platform, as well as my colleague Jillian, who's our AI Success Director, and she helps bridge the technical and business considerations. If we don't mind, perhaps you could get started, and I was hoping to go through some administrative matters. Can we request that you please keep yourself on mute unless you're speaking so that we can ensure an enjoyable experience for all our participants? If you have any questions, please feel free to post them in the chat box and we'll try and answer them at some point in time throughout the session. Do keep your video on. We'd love to see you virtually over here. And finally, we've got some really cool Datarobot swag to give away. So do stay tuned till the end of the session. There we go. I think our slides are a little laggy today, so do bear with us if it takes a little bit of time to load. The program for today's session is intended to give you a broad overview of Datarobot and how we partner with our customers to drive AI success into your agency. I'll start with an overview of Datarobot, which will be followed by a technical demo by my colleague Wei Chong, who will show us how easy it is to build an AI model in under 20 minutes. Jillian will then share with us some of the public sector specific use cases, and followed by a panel discussion with two of our esteemed clients, Mr. Bei Chun Hao from PDPC and Mr. Ricky Purnomo from IHiS, who will share with us how they have leveraged automated machine learning to drive AI adoption in their agencies. Now, Datarobot Mission is to help our clients accelerate their AI goals and drive transformation within their organizations. To that end, we typically see three broad objectives across the many customers we speak with. The first is to accelerate AI adoption and spur innovation, and in the process, transform your business processes to deliver more citizen-centric services that leverage AI. Excuse me. The second is to rapidly deploy value-adding, trusted solutions with insights to support smarter decision-making across the entire organization. Finally, we also see a need from many of our customers to build an AI-ready workforce, grooming what we call techno-functional experts with the appropriate technology skills but deep domain knowledge to be able to solve their specific business problems. And to help support these objectives, Datarobot offers a comprehensive AI platform that accelerates the development and deployment of AI with leading-edge monitoring, governance, explainability, and AI ethics capabilities, all built in directly into the platform. Our training in AI success services also helps us partner with our clients to cultivate the capabilities to enable anyone, whether it's a person starting on the journey of data science or an expert, to be able to build powerful machine learning models. Now, Datarobot was founded in 2012, and back then, our founders were data scientists in moderate-sized organizations who were trying to push to transform their respective companies and leverage the power of AI. But they couldn't drive the investments they needed as AI was so manual and resource-intensive. So they set out to be the change they wanted to see, and they channeled their energies and their learnings into a new company, Datarobot. They dreamt of an AI environment that combined the best of human data scientists with the benefits of machines to make AI more accessible to every company. We were very fortunate to gain an early investment to the tune of $20 million to bring this idea to life. It took us 3 years to build the product before we took it to market, and we launched Datarobot AutoML in 2015. The idea caught on like wildfire. Yeah, sorry, I think I hear some echo. The idea caught on like wildfire, and it enabled us to even create an entirely new category called AutoML. Since then, we've been fortunate to gain a further $1 billion in funding, and this supports our team of over 750 data scientists and engineers who've dedicated more than 2 million hours to building what we believe is the most comprehensive AI platform available. Now, Datarobot is designed to be integrated into your current environment and has been set up in GCC in Singapore. Our platform is both code-based and GUI-driven, and it allows us to bring AI to every area of the business and enables us to support stakeholders across a wide spectrum, from analysts to business intelligence teams to specialized data scientists. Our transparent approach has driven some of the world's largest companies, including 8 out of the 10 largest banks globally, who trust us to support their AI transformation. We've been validated at enormous scale by dozens of disruptors within the analytics space, including companies like Snowflake, Tableau, and Salesforce, who have not only invested tens of millions of dollars in Datarobot financially, but are also using it to transform their own business. Right here in Singapore, EDBI is also a strategic investor in Datarobot. But AI is not just about fiscal returns. It's there to make the world a better and more efficient place. To that end, we've helped organizations save lives by preventing forest fires. Our technology has been used to help the world have cleaner water. And we protect millions from fraud regularly. And we continue to be driven by that mission and our belief that AI should be accessible to all organizations. These are some of the factors that have led to our explosive growth. However, what we typically see with AI becoming more mainstream is more and more ideas are hitting the data science backlog. The ideas are coming from everywhere. They're coming from the business analysts, from executives, from leaders, from domain experts, all of whom have numerous ideas on how AI can be used to help them. But following the idea stage, the rest of the process falls onto the data science team. Working through the feasibility with the business, finding the appropriate data sources, working through the most effective model approach, and then all of the training and testing that goes into that. And from there, building integrations into applications, building deployment plans, and all of the documentation for governance, compliance, at times becomes a bottleneck because there's little support from the wider operations team due to a lack of understanding of the unique requirements that ML models need. Now, once models get into production, what we see is the benefits can often be short-lived because accuracy can diminish rapidly in the real world as training data starts to drift away from the real data that's used in production. Issues around efficiency of code can cause errors and scaling issues. And as we all know, even the most modern general-purpose monitoring tools do not support machine learning model-specific monitoring for areas such as accuracy, explainability, drift, and bias detection. All of these challenges mean that taking advantage of AI is lengthy and the benefits at times can be limited. And that's where Datarobot believes in order to be able to do this efficiently, it starts with a foundational platform that allows for consistency across the entire process, but without forcing anyone to use tooling they do not want to. The platform should be extensible to ensure interoperability with your current processes. It must be usable by all stakeholders, such as the business people, such as analysts, your data engineers, and data scientists as well. When it comes to deployment, we want to allow for collaboration between data science teams as well as IT operations teams, driving the standard deployment process that IT needs while keeping the processes suitable for AI as well. Most of all, we want to ensure that AI is trusted by the business once it's deployed. In production, you can use our consistent API to integrate your applications or to build an AI app with no code at all. With either option, you know that your models will be adequately monitored for data drift, accuracy, and even biases. And should a model become less accurate than an alternative challenger model, for instance, we can let you know and even automatically switch out that model for you. So that will ensure that your AI applications continue to operate at peak. And when we look at the opportunity there, we see that with Datarobot, you can effectively deliver your AI applications 3 times faster. Now, Datarobot is also a platform, a single platform where all personas can collaborate, from creators to operators to consumers. It offers an end-to-end functionality from data to ongoing management of models to consumption of outputs, governed, trusted, and explainable at every step of the way. It works with data from a wide array of data sources, and it can be deployed and operated in a multitude of configurations, starting with deploying it in your on-premise environment, or in GCC, within a virtual private cloud, within a hybrid cloud, or even on Datarobot's managed cloud. So with that, I'd like to hand it over to Wei Chong, who will take you through the platform and go on to show you a little about the product itself.
All right, thanks, Brad. Let me first start by sharing my screen. Just to check, can you see my screen? Okay, cool. Okay, thanks everyone. Good morning. Happy to see all of you here. So for the next 20 minutes, what I would like to do is to quickly show you, or rather give you an overview of what you can expect, when you're using Datarobot. So specifically, kind of going through the machine learning life cycle from actually building a model, deploying a machine learning model, visualizing the model, and then using the model. So what you see on my screen here is actually a kind of an end outcome of building out a machine learning model or building out a machine learning use case. This is a dashboard that you can build from within Datarobot. Like what Prem mentioned, this is done without any coding, which I can quickly show an example later. So my use case for today is I want to use a model to predict whether for a particular government grant application by private companies, whether or not they could be fraudulent or they could be rejected. So in any way, they are non-compliant in any way, or there needs to be a little bit more scrutiny. So you can see on my dashboard here, I have different data that's being used by the model. I can look at the grant amounts that the companies are applying for. I can know historically how many grants have they applied previously. But most importantly here, the model has actually already generated predictions for different incoming grants to the agency, and what kind of risk the model thinks for a given grant to be possibly rejected or fraudulent. So let's say when I click on a particular application, here it tells me the predicted risk score about 76%, and then the associated what we call prediction explanation. So different reasons why a certain grant could be risky or a certain grant application could be not so risky. So this is kind of the end point of building out a machine learning model or machine learning use case. You want to use the model to generate predictions and then to visualize the results so that other end users or other colleagues in your department can actually use that model to make kind of decisions and actions on the ground. So to even reach this point, that's where we need to start to build that machine learning model. So here I'm actually going into the Datarobot platform itself. So here, this is kind of like the landing page. You can see the starting point is always to ingest some kind of historical data or data set into Datarobot. So here, we can ingest data from different sources. If it's in one of your systems, we can make a connection or pipeline to it. Sometimes our users start off with a simple Excel or CSV file. That's totally fine. Yeah, but for us, what we'll do is actually we'll start off from a place called the AI catalog, which is this tab over here. So the AI catalog is kind of like a repository of a couple of things. One of them is data sets. So here you can see I have different data sets that I have kind of ingested into my own catalog. And what I will do is I'll filter down to the data set that I want to use for today, which is this grant irregularity data set. So when I click into it, it gives me some high-level information like number of rows, number of columns, and all of that. When I look at the profile, so this gives you an overview of what kind of historical data I'm using. I have things like for given given grant application or given company, how long has this company been operating? How many number of owners does this company has? The type of industry that this company belongs to. How many times have they applied for the grant? And so on and so forth. So various types of information that I'm trying to use to build that machine learning model. Now, the most important column here in this data set is this known fraud column, because this is the historical tag or the historical indicator that the model will try to learn to differentiate patterns or differentiate how a grant could be either rejected or fraudulent, or it's totally fine. So you can see this column is either a true or false value. So when I'm building the model, or rather when Datarobot is building the model, Datarobot will try to identify patterns that can allow it to differentiate between this true and this false indicator. So that's the data set. To start off building the model, what I need to do is to create a project. So on the top right-hand side, I have this create project button. I'm going to click on it. This will bring me to the data page, the data tab over here. So now I'm uploading the data and trying to prepare it a little bit more. I will do, or rather Datarobot will do a round of exploratory data analysis, whereby you will look through the data, do some first cut analysis, look at the variable types, calculate things like averages and standard deviation, some summary statistics, and you will also do automated data quality checks. So here again, it's the same data set, but just slightly represented slightly differently. So different variable types, my summary statistics. If I click into any of these variables or features, it gives me a histogram or a distribution. So right now it's just give you a visual of what the data looks like. We run those automated data quality checks. So we try to detect things like missing values, excessive zeros, inliers and outliers. So for now, for now, my data set is fine. So I'm going to proceed with actually building out multiple machine learning models. So I'm going to scroll to the top. Now, the kind of the question that I need to answer here is, I need to tell Datarobot what would I like to predict. So here, because again, I'm trying to predict whether the grant could be fraudulent or rejected. So I'll be using this column. We call this the target. So this will be my target column. And what this will do is Datarobot will start to build classification models to identify between this true and this false tagging, right? Which could be fraud or which could be rejected and which are okay. In the middle is the start button that says autopilot. So once I click on this, I will start to build out different machine learning models. I'll start to run the autopilot kind of program to try out many different combinations of models and pre-processing in order to find the best combination. Time-aware modeling is for something that's related to, say, time series forecasting, and I also can add additional data sets if I want to this model. So I'm not going to do that for now. I'm just going to do something simple. I'm going to click on the start button. So on the right panel, after I click on the start button, you'll see Datarobot will run through a sequence of steps. These steps are things like creating cross-validation, whole-up partitioning, univariate analysis, a little bit technical, but basically these are things that needs to be done to further prepare the data a bit more in order to proceed into the machine learning, or rather the model building process. So these are steps that, if the data set is given to, say, a person or like a data scientist to work on, he or she will need to actually kind of script in, say, Python or R or whatever, in order to build out those steps. Now, for now, the platform basically automates the entire process on the backend. Now it's closing, finishing to this preliminary step. So the last step is actually the most interesting, generating blueprints. So I will show you an example of a blueprint later on. And this blueprint is the series of blueprints that we generate are quite powerful. Basically, blueprints are a sequence of steps that the data will experience in terms of different types of pre-processing and in terms of different machine learning algorithms. And the end objective of different blueprints is to optimize predictive accuracy of a given model. So again, I'll show an example of a blueprint. So right now, again, on my right panel, the model building process has started. I have two models that's running. The first one is actually a deep learning model, and the second one is a random forest model. You need not care, again, too much about the technical details for now. And I have 2 models running, 30 others are in queue, right? So they will be waiting for their turn to kind of get started. Now in Datarobot, there's a concept called workers. So if you look to the top right-hand side, workers over here, the idea of workers basically allows me to parallelize the entire model building process. So let's say I increase the number of workers that I'm giving access to this project to say 20, which happens to be the maximum that I have for my account. You can see again that I'll be building 20 models all at once. Right? So this speeds things up quite a lot. And each model will take their time to run. As they are running, they will start to populate this models tab over here. So I'm switching to the next tab right here. You can see this number jumping as well. So once I click into models, I'll be presented with the leaderboard, right? So this is the leaderboard. So as the name suggests, it's really just a place for me or for Datarobot to rank models. Now rank by what? Rank by things like how well they perform in terms of accuracy, or rank by things related to how much error they are incurring on the data. So this the whole process of building out the different machine learning models and the entire project will take about 10 to 15 minutes to complete. So of course, we're not going to wait. What I'll do is I'm going to switch to a version of the project whereby the entire process has finished. So I'm going to switch over to this. So how do I know that this project has finished? It's the same data sets, my same grant fraud data set. You can see again on the right panel that Autopilot has finished. And for this particular data set, Datarobot has built a total of 45 models. Again, they are ranked on the leaderboard based on some metric. In this case, it's log loss. It's more of a technical metric. And at this point is where we want to kind of scrutinize the top few models in the leaderboard, because we don't really care, the machine learning models that are further down the leaderboard. We just look at the top. And what we want to evaluate are 2 things. The first is how well the model is performing. So model accuracy, things like sensitivity, precision, recall. We want to be concerned with all of that. We want the model to be accurate, to perform well. That's the first aspect. The second aspect we want to be concerned about is interpretability and explainability. So we don't want a model that is kind of black box in nature. We don't understand it. We don't trust it. We don't feel confident using it. So we want to evaluate these 2 dimensions in terms of performance as well as in terms of interpretability, all within the leaderboard. So right now, I'm actually going to click on the top model here. I'm going to click on it. The first thing that will show up will be the blueprint, which I was talking about just now. So this is a very simple example of a blueprint. You can see I just have 2 different types of processing, or depending on the types of variables that are in the data set, and then finally reaching the machine learning algorithm to generate the prediction. Now, this is a very simple blueprint. Let me show you something that's a little bit more complex. So in machine learning, not necessarily complex processes are better. Sometimes a simple approach will work better. So here you can see I have a slightly more complex blueprint, but the performance of this model is lower because it's lower on the leaderboard. So I'm gonna ignore this. I'm gonna look at the top model. So again, 2 things: performance and interpretability. So how do I look at the performance of this model? I can go to something like under evaluate, the ROC curve tab. So in this page or in this tab, it shows me all the statistics that I need to know on how well the model performs. So I'll just draw your attention to one of them, which is this confusion matrix. So this little table here, 2x2 table, tells me what are the kind of, how many, for example, true positives, false positives are being incurred by the model. So what is a true positive? True positive is something like, let's say the model predicts that it is a grant fraud, or this grant is this application is non-compliant, and indeed in reality it is non-compliant, or it is rejected, or it is fraudulent. So that's a true positive. Whereas something like a false positive would be like a false alarm. The model predicts that this should be rejected, but in reality this grant is perfectly fine. So what we want to do at this point is really to evaluate how accurate our model is in identifying true positives and true negatives. And then there will be other matrix, other type of matrices to look like for example, sensitivity, specificity, the raw accuracy itself, and so on and so forth. So sometimes we may spend a bit more time to evaluate the model performance here. But let's say I'm okay with this model, it performs well by my standards. Then I'm going to look at how I can interpret the model. So if I go to understand and then feature impact, this tells me what are the most important features or variables or headers in the data set that the model thinks are the most important. So here, the top feature happens to be business entity. So the type of entity the company is, followed by the grant amount, followed by the bank balance, and so on and so forth. So at this point, you can get some level of assurance to say what the model thinks is important. I also think this is important as a kind of a field expert or domain expert. So there should be some level of confidence here by looking at feature impact. But feature impact is very broad-based. It just tells me which is important, which is not. It's not granular enough. So something like prediction explanations will be a lot more granular because it tells me on a row-by-row basis, company-by-company basis, what is their risk score and what kind of explanations that they're giving me. And you can see that. So these are 4 different examples, like a preview of explanations that Datarobot is giving. You can see that even though 2 companies have very similar risk score, say like 5% and 2%, reasons that are attributed to them will be quite different. And that is where we can use the different prediction explanations to react accordingly on the ground based on the explanations that they are given by the model. And this makes interpreting the model a lot more clear. So let's say I'm perfectly fine again with the performance as well as the interpretation of the model. The next step is to put this model into production. And that's where I get one step closer to building the app that I was talking about. So this is where I'll actually deploy the model live. I'm going to push this model into production. I'm going to click on this deploy model over here. So what this does is it brings me to kind of the deployment page. Firstly, it brings me to the deployment page over here. And then it brings me to this page whereby I can set kind of a lot of details and how well I want to control the model. So what am I controlling? I'm actually going through, I'll be able to look at things like service health, data drift, things that you want to track and manage once your model go into production. So one example that I want to track is whether the accuracy of the model falls below a certain threshold. So maybe when I'm training the model, I have a 90% accuracy, but models tend to degrade over time. So let's say in the future, it goes down to 70%. So do I want to track that? And if I want to track that, what can I do? Can I retrain a model? Or do I just send notifications, things like that? So all of these will be controlled before you deploy the model. So let's say I'm going to start with something simple here. I just want to track the service health and track the prediction history of this particular model. The other more advanced features, I'll ignore them for now, and then I'm going to create the deployment. So once I do that, basically this is creating the model, deploying the model live. It brings me to this deployed model page whereby you can see I just deployed the model, some high-level details of the model, and so on and so forth. Now, to zoom out a little bit, when I go back out to the main deployment page, this gives you an overview of all the different models that I've deployed in my organization or in my agency, and how are they faring in terms of different metrics like their service health, whether how many are passing, how many is failing, data drift, accuracy, and all that. So, for example, if I click on a given model, I can look at how many predictions has been generated by this model, how many requests were made, whether there's any error and all that. When I look at data drift, I can see the changes in data distribution between the data that I use for historical model building, as well as the data that has been kind of fresh and live and used for scoring. That's future data. So the idea is that if there's a shift in the distribution for the training data compared to the future data, so historical data and future data, what we want to do is to retrain the model. We want to retrain using a newer or more recent data. So this, on the right-hand side, this is actually one example of data drift. You can see on my dark blue kind of charts, right? Dark blue bars. Those are training or historical data distribution. Suddenly on the light blue, which is my future data, I'm seeing values that I haven't seen in the past. So this kind of a hint for us to consider rebuilding a particular deployed model. Tracking accuracy. So here it's a very simple overview of how well the model is performing over time. So we track different metrics and how they fare over time. Again, the premise is that at any point in time, if the model degrades beyond a certain threshold, we want to retrain the model. So let's say we deployed the model. The next, kind of the last thing is to actually create the app so that other users can use it. So to do that, we will go to this applications tab. So I already created a number of apps here. I'm just going to open one of them, which is actually the same one that I created. I've shown you right at the start of my demo. So this is the app. Just to quickly show you how easy it is to build the app. All I need to go is to go into the build mode, and whatever charts and widgets that I would like to build out, all I need to do is just to drag and drop them into my app, and then again configure them based on what I want to visualize, like the different features or the different headers that I want to show, and then start to build out your app from there. You can customize it and all that. But the end objective of building this app is really to ensure that users can use your model without, users may be able to use your model, be able to visualize your results, be able to generate predictions, something like this, not without even going through the entire model building process. So these are meant for end users who are not so familiar with machine learning, or this is really a good way for you to make sure that the model is consumed by other users. So with that, I will end my demo here. Back to you, Pran.
That's me. Now, thank you, Wei Zhong. Hang on, let me just bring out my slide. Okay. Thank you very much for the very comprehensive tech demo. I hope all of you will have a good flavor of what the Datarobot platform has to offer. I mean, in gist, if I were to summarize, the Datarobot platform is just one that really lowers the barriers of entry for you, anyone who wants to develop, deploy, and monitor any machine learning models. But for successful AI adoption, I mean, other than technology, we also need to take care of two other very critical elements, which are the people and the process, right? We do that through our Datarobot so-called AI success approach. And the AI success approach is a very structured and customized approach where we will work with you to chart out the plan and also the roadmap to drive successful AI adoption and implementation. So the AI success approach, the plan can be very customized according to the level of AI maturity in your organization and also the specific needs of your agency. Now, at different level of AI maturity, the needs would be very different. So if you are, let's say, if you look at the slide, if you're just starting out and on the lower level of maturity and starting out on the AI journey, the focus would be really to choose the right model, prioritize it, and know what is the use case that would generate the biggest value and generate the momentum for your organization. Then focus on deploying and iterating rapidly. Now, if you're at a slightly more mature stage, let's say at this stage 3 where it's integrated data science, then the focus would also be very different. It's to centralize and to govern some of the AI operational functions, build up capabilities across the whole organization on machine learning capabilities. So that's what we do in the AI success approach. The good news to you is the AI success activities and the services are available in the bulk tender. So there's a range of activities that can be easily accessible to you, which we will share a little bit more later. Now, the most common question that we always get from people that we meet is, what are the use cases that you have done and what are the use cases that is possible? So today we have, for your benefit, we have kind of summarized some of the possible AI use cases for the government. Some of them are implemented in the local agencies, local government agencies. Some of them we see them across the world in the governments across the world. So they are kind of classified into broad categories on this slide. I won't have time to go through each of them, but broadly in customer service, we can look at the more targeted digital service offerings. Can use AI to better classify and route the emails or do better demand forecasting or resource optimization. That's on the service end, and that's all in the name of providing better service to the public. And in the compliance realm, a lot of it is on risk scoring, prioritizing what are the top risky cases for you to invest your audit and investigation resources into. And sorry, my kid decided to play the piano now. Give me a moment.
Those are the joys of working from home, right?
Sorry, just like when I started, they decided to play the piano. Sorry about that. I was trying to live with it. Pardon me for that. And so on the compliance realm, there's the risk scoring, which I talked about. And the very common thing that we're all very concerned about is the fraud detection and also predicting, risk of default. Oh, sorry. And risk of default for payment or anything. So that's all on compliance. There are also many use cases around operations and specific domains, like in predictive maintenance, on healthcare, which we'll also hear from our panelists later. So the use cases are not just restricted to the front end kind of operations. In the back end, the corporate functions across finance, procurement, HR, and IT, we are also seeing a whole range of use cases. Some of them we have implemented, like in the finance space, there's the invoice anomaly detection, or just using AI to detect out of policy claims that streamlines the human effort to kind of review them manually. Across procurement, there's procurement fraud, or HR, there's talent forecasting and management. So the list goes on. Unfortunately, we are unable to deep dive into many of them, but if you are interested, we're very happy to have a chat with you separately and let us know what are the use cases you're interested in, and then we can arrange a separate session with you. Okay, and now that is, before I go on, there's a link at the top. If you are interested, you can go to the Pathfinder website on Datarobot to take a look at some of the use cases that we have. Now, so this is a really good segue to what is the highlight of today is our panel discussion with two very esteemed panelists who have been clients of the Datarobot for a while. So let me introduce you to the first panelist, Mr. Bei Chun Hao. Chun Hao is the Director of Consumer Services and Investigation with the Personal Data Protection Commission, which is PDPC in short. Now, PDPC is the authority that deals with all matters relating to yours and my data protection. Now, Chun Hao's team plays a really important role in resolving and investigating all the public complaints on data breaches. Later, we will have the privilege to hear from him on how his team uses Datarobot to manage the high volume of complaints. Hello, Chun Hao. Are you there? You want to turn on your video?
Hi, hello, everybody.
Hi. Yes. Hi, Chun Hao. Thank you for being with us today. Let me just introduce our second panelist, Ricky. Ricky is the Deputy Director of the Data Analytics and AI team from IHiS, which is the Integrated Health and Information Systems. IHiS is the tech agency that takes care of the whole public health sector. They have been really doing amazing work to improve our health and the health administration system using technology. In particular, Ricky himself has driven many successful data science and analytics projects. So let's look forward to hearing from him later. Hi, Ricky.
Hi, morning, Gillian. Thanks for the introduction. Right. Good morning, everyone.
Hi. Okay, let's kick off the panel with a question for Chun Hao. Now, Chun Hao, we know that PDPC has achieved great outcomes, right? Using machine learning to process the large volumes of emails and complaints coming from the Do Not Call registry. Could you share a bit more about the use case with us and how it has helped your team?
I will not say great outcomes, but definitely our things are very happy outcome. So we process about 1,000 such complaints every month. So we have a small team of complaint managing agents, and we also outsource some to our call center agents to help us read the emails, answer the phone calls, right? So this small team, I would say when they all add together, it's less than 10, right? So they have to deal with sifting through this 1,000 a month. So they will have to burn weekends, burn midnight oil, that sort of stuff, just to ensure that the numbers don't pile up, right? So it's actually not a very, I would say, easy job to do. So luckily we have our senior manager who thought of the idea to see whether, why not we try to see whether we can actually adopt technology to actually help us, right, to make the job easier. So she came across, I think maybe Gillian's predecessor has done a good job. So she came across Datarobot, she learned about that possibility. So she explored it further. And of course, at the time, we also have this, I think because of all this transformation push, right? We have all this innovation competition going on, right? So to marry the two together and really to focus on how to make the job easier, we went in to actually engage Datarobot to see what we can do, right? So cut the long story short, we got a lot of assistance from the company. The core team works very closely with the company to actually put the AI. Of course, the process is not very straightforward. There's a lot of learning kinks to be ironed out along the way, but at the end, we do achieve a very good outcome, which is that in the 1,000 monthly or so, monthly numbers, we are having the AI helping us clear 400-500 per month automatically without human intervention. So we are actually looking about half the load of all our officers handling all this complaint management taken off their desk. So this is the outcome that we are seeing. So the call center vendor actually bill us right on a per complaint handled basis. Each email they handle for us and each phone call they handle for us, or each complaint they handle for us, there's a contracted sum that we will pay them. So by reducing it by 400 to 500 a month, actually we have savings that we can actually compute and tabulate for our management to show the actual outcome and the benefit of actually having this. Of course, that the intangible part about saving time, which I mentioned earlier. Also, very quickly, this is it. Gillian.
Thank you so much. So for those of you who are next time going on to PDPC's website to write an email complaint, you know that there's a very intelligent AI system that's running at the back. Now over to you, Ricky. I know there's also very interesting use case from IHiS end. You have deployed some models like the NoShow model that has direct impact and tangible benefit on the patients in the hospitals. Could you talk us through like the objectives and the methodology for this use case?
That's right. Thanks, Gillian. Yeah, indeed, NoShow is one of the pioneering AI machine learning application that we put forward in the public healthcare space. So as the name mentioned, NoShow, the area that was being tackled is the fact that there are patients who don't show up for the appointments that they make. So you can imagine that can lead to various problems. Among others, there'll be resources that are underutilized. They are standing by for appointments but not used. But actually, equally important or more importantly for us is that it deprives other people of opportunity to be served. There are other people who may get an appointment earlier, they cannot make it earlier, they have to wait for somebody who turns up, hey, they're not using up their space. So you can imagine there's a driving impetus of how to solve this. So around 2016, there was this thought at the early time, right? Hey, there's a new area of data science. What if we can use data science to help address this problem? Because in healthcare, there's sufficient data captured on this. IHiS being the IT custodian, we manage many systems and there are a lot of data that are captured in various systems. Can we leverage on that? So that's where the journey started. And so we put into place this AI initiative to do a pilot how we can use this. And how we do it, we don't view this as just a data science project, although it is driven by data science. Our approach is incremental. We want to start with a proof of concept at a smaller scale. IHiS as a public healthcare custodian do have the data for all the hospitals in Singapore, but let's start with one or two institutions, see whether it works, whether the model performs well enough, and we incrementally scale up from there. And also we do it as a team sport, as in we are not looking at this as a AI or data science research. We want to see this being deployed, being applied. So what we do is that we do 3 steps. First is to understand more before we start any work. So this understanding is twofold. One is understanding the workflow on the ground that leads to all these appointments. So our team have conversations with the operation team in the hospitals, with the doctors, the nurses to understand the flow, understand the challenges. While at the same time, we try to understand more the data which is already available in the various data warehouses to see which one are relevant to try to do so. With that understanding, then we try to do the first cut of the model, the proof of concept. That is the development stage we will do. We start doing some model training. and iteratively try to find different ways how to see, hey, is there any algorithm that we can use to make this proof of concept really show good results? This is where we use Datarobot to help accelerate the iteration and the prototyping. And once we have that, then the final part is to see how this is going to be operationalized. Again, a model which is good, but in the lab is not as useful as something that actually can be used by somebody on the front line of the operation. And this usage is something that definitely is have to be done in consultation with the operations team. So we work closely with them on actually what intervention do you want to do once you know this information. And in fact, this is quite relevant because in the end, we've managed to roll it out to one institution and then slowly expand it to other institutions. What may need to be recognized is that for the same model, the way it's operationalized, the way it's used may be different for different organizations. So we have institutions, hospitals who say, okay, now that I have this, I know who are the people that I may need to follow up, give a call, a reminder, maybe 1 week beforehand, so that it's more likely that will show up. For another institution, they say, hey, actually, I already have these people. I already have call center who are already doing this for everybody. And then their use case is a bit different. For them, it's more like, how do I maintain the same level of people that are reminded and show up, and perhaps optimize my resourcing? I don't need to call everybody. So maybe in the future, as I have more appointment call, I don't need to hire new people just to keep up the same level. Maybe I can do it in a more targeted way. So this is the context where the operationalization, it is something which is relevant for the data science team to still work closely with how this is actually going to be used. So that's how IHiS deploys this NoShow, and this is also our approach for our various AI models.
Thank you, Ricky. I think that use case is especially relevant now that the healthcare resources are really stretched. So thanks for sharing. Now, Chun-Hao, over to you. PDPC, we know that you have made pretty decent progress in your AI journey. Now, I'm sure there have been challenges, right? What are some of the key challenges in using AI and machine learning, and how did you overcome them?
One challenge that comes to mind is when we were just starting out, we sort of like bite off more than we can chew. In a sense that we wanted the AI to actually help us triage the whole spectrum of the complaints coming into PDPC, right? To actually understand the kind of complaint they are, what kind of complaint they are, should they be taken up? And if they are not taken up, how should we deal with them? And if we deal with them, where should they go, right? So there are a few variables and a few objectives. So we are biting off one huge chunk. We want the AI to do so much for us, and we embarked on it, right? So we did a lot of data cleaning, understanding our data, sort the databases. I think they did entire 10 years worth of data that we have collected in PDPC for all these complaints. So it's a lot of work, and it actually went to vain. Why? Because of the multiple variables that the AI has to grapple with. The confidence level actually didn't quite meet the kind of high confidence level that we look for. So, but we enjoy the experience. We learn from the experience. There's a lot of takeaways from the experience, and we have to actually credit the experience, because it is in the course and the midst of doing that, we realize that, hey, actually, if we were to get to a high confidence level, then we cannot throw so many variables to the AI, right? If you want to get that kind of a high level confidence level, so we limit the scope, and when we think about how to limit the scope, we thought, why not we approach the problem in another way, right? In order instead of getting the AI to triage for us, to find out what to do with the whole spectrum of complaints coming in, why not we identify biggest bulk of the types of complaint, the classification that is the largest in size, and have the AI identifying, predicting correctly this category. And just by dealing this category, which is the needle moving category, we actually can cream off this huge bulk off from our load, which is the original intention after all, right? So we did that, and the variables came down, the confidence went up, and fingers crossed, till date, because what the AI is doing is they'll identify the category correctly, and they will automatically dispatch this complaint to other agencies. So imagine the AI fails us. I'm going to receive plenty of phone calls from the management of this other agency to say, hey, what is your staff doing? Why are they chugging so many complaints that is not my portfolio to my guys, right? So I'll face that kind of issue. So it's there is certain risk there, but fingers crossed. So far we have 100% correct dispatch to the other agencies. So much so that we are actually thinking of whether or not we can dial down the confidence level slightly, so that like what I mentioned earlier in the earlier part of my explanation, right? We are dispatching like 400 to 500. If I drop the confidence level slightly, if I take a little bit more risk, the numbers can actually go to 500-600, right? So it's a bit about adjusting the how much risk we are able to take, right? So that's some of the challenges that we have faced, but it's I would say that it's a learning that we appreciate.
Right.
Yeah.
Thanks a lot, Chun Hao, for sharing that. That also provides assurance to all of us who have been trying and experimenting in use cases. It doesn't always get it right at the first time. It's a lot of experimentation and extracting the learning points and shortening the deployment and learning cycle, right? Now, over to you, Ricky. I have a question, right? IHiS has been one of the first few agencies that started using Datarobot, actually back in 2016. And I think you're considered one of the pioneers in the government in the use of automated machine learning. And at that time, automated machine learning was still a relatively new concept. So at that time, what triggered IHiS to use it?
Yeah, indeed, it was a bit of a leap of faith as a pioneer. We dive in because we believe in the promise that it offers. And at the same time, being pioneer means the difficulty is how to get started. One of the big challenges last time is that, okay, let's build a data science team around this project. Now, where do we get these data scientists? So in the past, when it first started, yes, we are hearing about those very good data scientists, but they're scarce. So the team at that time still small, and how do we scale up? How do we have enough team to try to tackle the various available opportunities that we have? So we couldn't move fast enough. That's where it triggers, hey, what if we have a tool that can help that this small team can be a bit more productive? We can try to iterate and do things faster and more. So that's where the initial impetus, okay, let's find a tool to automate some elements of the exploration of the machine learning. And that's where we came across Datarobot at that point.
Thank you. Very, very interesting. Okay, the next question is to both of you, Chun Hao and Ricky. I know that their two teams have very different profile of staff. Chun Hao's team has more business users, and I think Ricky's team has more technical, I think some PhDs and data scientists. Please share with us, specific profile of your team members and what was their specific experience in using these automated machine learning functions. Maybe Ricky, you want to start?
Sure. Yeah. I mentioned just now we're trying to build a team from data scientists in 2016. At that time, it's single digit. By now, we are double digit. We're quite fortunate that we've managed to build a team that grows and is diverse. They are primarily technical in the sense of analytics technical people, so they would be comfortable creating machine learning model with Datarobot or without Datarobot. And they are diverse in the sense the background comes from, you would expect things like analytics skills, statisticians, but we also have people who are engineering background, computational biology, and we at one point have a colleague who was a quantum physicist. So the fact is, if you are data driven and you are numeric, you can come in and there are tools like Datarobot that can help. So they primarily use Datarobot in this sense to help them move fast, similar like what I mentioned in the experience for NoShow. It helps the team to experiment more. They can try more different algorithms rather than they handcraft the solution. And also in the sense that when they try to go into operationalization, at that point, not only do we try different algorithms, we start trying to see if this model performs for different scenario, how does the metrics, how does the performance change? And they use this Datarobot in a way as a way to quickly evaluate the various metrics, the various numbers that come out, the various different simulations. So that's how it has been used among our team.
How about you, Chunhao?
Oh, I must say I envy Ricky's resources. Yeah.
It's time to know. I'm sure you will get there. It has been 6 years.
Okay, the core team, I have two, like I mentioned, one senior manager and one investigating officer. So two of them in the core team. Of course, during the cleaning process, data cleaning process, they did enlist help from others. Now we have one more assistant manager to actually help the senior manager with keeping an eye out for this the performance of this AI engine that we are using. All three of them, or rather the two of them, do not have a technical background. All right, one is investigating officer, one is actually a management role. Both of them took up 2 days crash course by Datarobot to actually teach them how to use the application. Then they just take it and go. So I'm proud of both of them. Yeah.
Wow, that's quite amazing and inspirational for many aspiring citizen data scientists out there. I think we're running out of time, so I want to take one last question, maybe to you, Ricky. What are some of your plans for IHiS and the use of Datarobot to progress the use of AI in healthcare?
Okay, yeah, we are continuing to grow this area. The team is growing, our ambition continues to grow. I think we've tackled quite a lot of problem statement across the landscape, all using mainly structured data. We have a lot of tabular data, but there are other data in healthcare that we want to use more unstructured. For example, free text clinical notes from clinicians and also image data. In fact, recently in the news, Minister Ong shared a model which is developed jointly with IHiS and an hospital here, CGH, where we make use of X-ray images to identify patients who are likely to develop more severe cases of pneumonia. So those are examples of usage of a wider range of data, in this case image, that we hope to go more towards, and we continue to want to find ways to be able to, similar like our other models, iterate quickly so that we can just churn out more.
Okay, thank you very much. Thank you for the generous sharing, Ricky and Chunhao. It's very, very nice to have you here today. Now, let me just show you this one. After all the sharing, I think those of you who are on the call would be quite interested to know what is available in the bulk tender. We are definitely a bulk tender vendor, and it's going to make your procurement a lot easier. So this one slide kind of summarizes what is available. Obviously, the Datarobot platform, the software is there, so you can get access to data prep, automated machine learning, automated time series, and ML ops kind of prediction. These colorful boxes that you see here are what I shared about earlier in terms of the AI success activities. Basically, if you see on the left-hand side, it's just a series of events that helps you plan, execute and launch and monitor the progress of your AI initiatives and use cases. And right at the end, we are also focusing very heavily on enabling and training up your team, like what Chunhao has shared with us earlier, going through the course and enabling them to develop machine learning models on their own. Right, so I think we can pause to take questions. Let me just open up to the floor first. I see there are some questions in the chat, but let me open up to the floor. Is there anyone who has any question that you want to ask? Okay, then let's take the questions through the chat. Wei Zhong, can we get your help to share what are some of the data sources that Datarobot can take in. There was also a bit more specific question on, can we take in images, extract information, key value pair?
Yeah, so actually the data sources that Datarobot can ingest from is quite, I would say it's quite varied and agnostic. Images definitely yes, a key value pair definitely yes. So it really depends on how we format that information. But in general, as you can see, from the way Ricky's team and Chunhao's team have been using Datarobot, actually we are quite agnostic in those type of ingestion. So I wouldn't say that, yeah, so it shouldn't be an issue.
Okay, thank you. I think there's also another question on data engineering, right? What are the data engineering capabilities? I know, Kelvin, thank you for putting it in. Maybe it's also good to just elaborate and share with you about our data engineering or data prep kind of capabilities. Rachel?
Yeah, so for data engineering and data prep, it really depends on the type of comfort level in terms of scripting, because we have very varied users. On one spectrum, those who can code and can write full-fledged, say, ETL pipelines. And then on the other spectrum, we have users who are a little bit more comfortable, or in fact, they are only comfortable with GUI-based type of interface. So in the Datarobot platform, we have both types of data engineering options for you to choose from in terms of how you want to tackle data engineering and data prep. Yeah, so code-based or GUI-based.
Okay, cool. Sorry, I think we are running out of time, but we are very happy to have further conversations with you. We have a QR code here. It links to a Google form. Please let us have your feedback for this session. Within the form, please also put in your name or contact details if you would like us to contact you later to answer some of your questions, share more about the platform, share more about the use cases and everything. Any questions, please put it in and I will follow up with you there after this session.